All right, everybody. Thanks for showing up this afternoon. My name is Clayton Davis. I am the head of data science for Monty, and today we're going to talk about automatic containerization of AI ML models and how you can automatically turn a model into a production-worthy container using Chassis, which is an open source project that we kind of started here at Monty and has since put out there in the world for folks to use. Before we get started, talk a little bit about the upcoming kind of talk schedule. Today, we're going to go over automatic model classification. And we've got some interesting things coming up the next few weeks. Computer vision deep dive, an overview for gRPC for those of you interested in what procedure calls, and then running models at the edge. So how you get your AI models out to edge devices so that they can be impactful and running out there. So for today, agenda-wise, what we're going to do is we're going to talk a little bit about why you want to containerize a model. And that's going to lead us into kind of what Chassis is, its purpose, kind of an overview of how Chassis goes about achieving its purpose. And then I'll do a quick demo, and we'll follow that up with kind of an understanding of what went on during the demo in a little more depth. And then we'll just kind of finish up with some questions. So I think the first question that we should be addressing here is kind of like, why do we want to containerize models to start with? And the short answer is that if you don't containerize your models, the odds that they're going to be impactful on a large scale for the organization or the company you work for is pretty minimal. The sort of deeper version of that has played out in pretty much every company and organization that I've worked for and supported over the last, say, 10 to 15 years, in that organizations typically have a well-established kind of IT department, and I'm going to beg forgiveness to kind of stick the DevOps teams under that umbrella for a moment here. And that department and those teams, they have a well-defined way in which they get software and microservices kind of out to the company and out to users. Okay? Those policies are in place for security and maintenance reasons, and to make sure that the reliability of the overall infrastructure is maintained long term. These organizations have been in place for decades now at this point, and they're kind of just standard operating. They're kind of a standard operating hook there at all of the companies. Whereas over the last, say, 5 to 10 years, what's happened is that companies have started to try to grow data science teams inside their organization. And these guys have a very different mission than the DevOps teams do. The mission of the data science teams are to comb through the data that's available to them, usually it's proprietary company data, and try to gain some sort of kind of market insight or competitive advantage for the company or the organization that they work for. Right? And as different approaches and techniques have come out of academia and into the marketplace over the course of the last decade or so, data science teams have gotten really good at creating models that have high metrics, high F1 scores, precision, recall, accuracy, that find the sort of needle in the haystack style insights that the companies who are funding them are looking for. What happens, though, is that these data science teams get to the point where they have a model and it's functioning really well, and now what they want to do is deploy it, okay? Where deploy is kind of a nebulous term at that point. And so this is the first sort of situation which you'll start to see friction that kind of emerges between data science teams and the DevOps teams, because the data science teams will say, I have a model, I want to get this out to provide value to the company and the organization. And the DevOps teams will look at these models and tell the DevOps team, and tell the data science teams that they can't deploy that. Right? Like a model is just a file. It's not deployable. It's not executable. It's got a list of dependencies, right? It's got runtimes that need to come together. And if you really want to deploy this model in a sense, what you're asking is for a long-term operations and maintenance tail that's just not acceptable from the DevOps team's perspective. And so if you want to be able to deploy your model in a way that can be impactful to the company, what you really need to do is go follow our best practices, which means you need to take your model and package it up in a way that we can robustly and reliably distribute. And that means you need to go learn how to put that model into a container. Now, what happens next really kind of depends upon the size of the organization. If the organization is dedicated to the data science team, is providing the people, the time, and the money necessary to really push the products that are being generated by the data science team, in this case, the model, then the model has a decent, roughly, I'd say 50% chance, I think is what Gartner tells us about models that are generated in a research and development environment. There are odds of making it out into production. They have kind of a decent chance of walking the path that it's going to walking the path between R&D and a production container for their model, right? But if they don't have a champion within their organization that really will give them more resources, models tend to die on the vine. And the reason for that is because data science teams typically don't have the expertise that's required to take a model and then move that model from just a simple file sitting on their computers or their IT infrastructure somewhere into an executable container that the DevOps team can do something with, right? They don't necessarily have software engineering expertise or CI/CD expertise or Kubernetes expertise or Docker expertise. And those are all things you really need in order to move a model from an R&D environment out into a production environment. And so that idea, or the idea that models are best served in containers and they have the biggest impact in containers because they're easily deployable in that fashion, they're easily maintainable and they're robust in that fashion, it was one of kind of the core tenets at Monty when we started building the platform here a few years ago. And what we found as both we walked along that path, and we walked several of our customers and clients through that path, were that there were several sort of decision points along the way. And there were kind of these common trip points where we found that most people would start to kind of fall. And at those particular trip points, whether they were what languages should I use, what frameworks should I use, what ports should I make available, how should I package up this model and provide it out into the world, should it be a server, should it be just some REST endpoint, kind of, etc. What we did was we started to codify the lessons learned along the way and the best practices and to refine the lessons we were learning and the practices that we were undertaking. And so we got to the point that we could kind of walk that path with very little deviation from an R&D environment out into a production environment. And when we got to that point where we basically have a formula to take things from the research into the production paradigms, we codified it, and then we donated that IP back into the MLOps community through the Open Model Initiative. And so I encourage you to, if you haven't, to go take a look at the Open Model Initiative at openmodel.nl. It kind of goes through some of the thought processes, not just the thought processes, but also the specifications that we settled on after looking at multiple attempts to move machine learning models from a research environment off into a production environment. And it deals with things not just like how you should arrange your models, but also some of the more mundane things, like how do you communicate to your DevOps team how many resources you need to run your model, what ports they should be looking for and forwarding to incoming requests, how the data should look when it's coming back, and just simply what the inputs should look like. Those sort of kind of mundane tasks that generally fall within the skill sets between the data science team and the DevOps team who would be receiving the container at the end of this whole process. And once that OMI spec was in place, we realized that we kind of needed a way to generate OMI compliant containers that was simple. Right? It's one thing to have a spec and to define it. There's still a lot of sort of DevOps and engineering that has to go on to comply with the spec. And so what we decided to do was go ahead and put together a software implementation that would take a just model that was coming out of a data science team and convert that simple model file into the runnable container that we knew people were looking for, and was also compliant with the OMI spec that we had just kind of donated back to the community. The fruits of that labor became what we call Chassis. It's an open source project specifically designed to move your models, to turn your models into containers and to make them available for you to run anywhere. And so as we developed Chassis, right, we had to think about what its actual purpose was. And like I just said, the idea for us was to provide a simple mechanism to allow AI models that were developed in a lab or on specialty hardware to be transitioned so that they can run anywhere. And when I say simple, what I mean is that Chassis is designed and its purpose is to exist so that data science teams who don't know anything about DevOps can use the skills that they do have, right, which is just coding. And when I say coding, I mean just a few lines of code to get their model into that container, right? And when I say that I want it to run anywhere, I really mean anywhere that we can imagine a container might have a use for serving up an AI sort of model, right? So when Chassis was first being developed, we made sure it could run on CPUs, and then we extended it to make sure it could run on GPUs and take care of deep learning style models. Then we went ahead and extended it further when we started thinking about IoT sort of devices, made sure that it could run on ARM, and now even ARM with GPU. Right? So Chassis has kind of gone on this journey of developing a mechanism for end users who have kind of basic data science or basic coding skills to be able to take a model and then transform that model from just a file sitting on someone's computer to a container that can execute that model and sit anywhere that compute resources may be available, whether it's a desktop, in the cloud, or an IoT device. Real quickly, we'll kind of talk about the sort of three main stages for Chassis, and then I'll go ahead and I'll show you a demo of all of this working together. The three main phases of Chassis are kind of this local packaging, some server processing, and then container storage at the end of our pipeline here. In the first stage, in the Chassis local packaging, what's going on there is that Chassis, through an SDK that you can pip install on your local machine, will gather a model that you have built, and through a sort of process that requires a couple of different function calls, it'll gather extra information for you about the type of data that you're expecting, naming, versioning conventions, those sorts of things, and we'll wrap your model along with that ancillary data to push over onto the Chassis server. On a Chassis server, the underlying system will unpack your model and then couple it with some boilerplate Docker files and a gRPC server and a couple of other things sitting there under the hood that are compliant with the OMI spec, and combine both the boilerplate data and boilerplate files along with your model and your input samples to send off to an open source project called Canico. Now, Canico will take the OMI compliant sort of underlying boilerplate along with your model and then merge them together to create a container on the very end, which is capable of running on your CPU or your GPU, your ARM, wherever you want it to be, and ship it off to a storage location of your choosing. The current default happens to be Docker, and so the overall processing pipeline is model in, Docker container out, sitting in an easily accessible public location. And with that sort of understanding, we'll go ahead and do kind of a quick demo of Chassis running. And so what you can see here as I scroll up to the top is we're just looking at a simple notebook. This notebook is actually part of the Chassis Git repo, and so anyone who wants to go and take a look in the Chassis Git repo can get access to this notebook sitting underneath the SDK and then the example directory. Right. And so the way in which Chassis goes about functioning for an end user is to simply import the Chassis SDK through the import Chassis.ml. And then what you'll see here as I go through is that we're going to have to go ahead and kind of not just import Chassis, but also build a quick model so that we can actually demonstrate the way that Chassis is going to package things up. To do that, we go ahead and we import Chassis, we import the modules we're going to need to build the model. And we're also going to go ahead and import some authentication tokens for Docker Hub. Remember I said earlier that we're going to go ahead and push this to Docker at the end of our process. With our authentication and our modules loaded up, we'll go ahead and we'll train a quick model so that we can demonstrate Chassis wrapping that model. The model we're choosing to wrap is a very simple one. we're just pulling the standard digits data set and building a support vector classifier using sklearn, and then just fitting it here in this last line. So with that model available to us, we're now at the position of most of the data science teams when they're going to go ahead and begin to try to use Chassis. Okay? We have a model that exists, and we need to be able to generate two things for the Chassis project to actually containerize our model and to go from just that model file into the container. The first is that we need to provide access to our model from Chassis. And we do that in this cell that you can see right here by passing the model, or by adding the model into a dictionary that has very specific key value pairings. In this case, we just need the key of model to actually access the object, which is to access for its value, the model, which is your classifier, or whatever your model happens to be. So having provided this dictionary that has your model in it, we then need for Chassis a processing function. Now this processing function is the way in which you're going to tell Chassis how to take data that's coming into your model and to do any sort of pre-processing to it before you run inference and then any kind of post-processing. It's akin to the sort of predict methods that you see in sklearn, with the caveat that not all data coming in is necessarily going to be as clean in the real world as it was in your R&D environment. So we encourage people inside of this model to also add in these pre-processing steps to do data validation, etc. And then obviously here, once you're done with the inference, to go ahead and structure your output in whatever way happens to be meaningful to your end user. In our case, we're going to pull in the digits data, turn it into a NumPy array. We'll run a prediction on that NumPy array to determine what digit has been sent to us, and then we'll go ahead and structure the output via JSON. Okay, so with those two things in place, access to your model and access to a processing method that can take in data, validate it, run it through your model, and generate an output, what we can do is go ahead and actually start the Chassis part of the processing. So the first thing that we need to have is a Chassis client. This is kind of the area on the left of that slide that we just showed. This is what's going to work for us locally here and package up our model. And so simple instantiation from the SDK, which includes a URL that points to the Chassis service that's going to be doing all of the processing. I'm actually running that Chassis service locally here on my machine. But for those of you who want to go ahead and try this out on your own computers at home, you can follow the Chassis.ml website's implementation for using the Helm install associated with a simple Kubernetes setup to get access to a server yourself. So by running that instantiation, I get access to a Chassis client, and then I use the Chassis SDK's create model method to actually create the model that's going to be resident inside of our container. And so the reason that we have this is because we need a model that has kind of a standard set of inputs and outputs in order to comply with the OMI spec. And so this particular method right here takes in your model via that context variable from earlier, as well as an understanding of how to process your model or data through your model through that process function that you just created here a little bit earlier. And it returns what we consider to be a Chassis model, which is just an MLflow Python model with a couple of extra extensions on top of it. In addition to that, in the cell, we'll go ahead and we'll grab some input data and we'll run a test to make sure that the results correspond to what we expect. And in this case, you can see we are in fact getting back the same sort of structured JSON that we told the processing device that we needed, the processing function we needed to have returned to us. So with those two lines of code, right, creating the Chassis client and then converting the Chassis model, we have everything we need to actually tell the model to publish. And so we will go ahead and kick off the publishing method. This method is actually pretty simple. It just grabs a name that you want to associate with this model, a version associated with the model, and then all that authentication data that we provided earlier in this notebook so that once the container has been created, it can go ahead and be pushed off to Docker Hub. So this particular cell, the block until complete is a synchronous call. You can obviously do it in an asynchronous way if you wanted to. And so we'll just go ahead and check real quick and make sure that the chassis service kicked off. And indeed it did. What you're looking at here is the Kubernetes cluster that runs the service, that middle part in the slide that I showed you just a second ago. Now, this process, how long it takes, is going to depend a lot on the resources that are available to you and what all needs to go inside the container to make it functional. I just did this one, a little bit earlier today. It took about 8 minutes. So, in the interest of time, since we're kind of coming up to the end of the tech talk time here, we're going to do the cooking show thing, and I'm going to show you that the Docker Hub account here has my model in it from a little bit earlier today. This is kind of the endpoint of the entire chassis processing. This is where the one that's currently processing will end up shortly. So now my model that I built at the very beginning of this notebook and didn't exist before I started has been taken, converted, turned into a container, and put up here on Docker Hub, where I can now pull it down and use it wherever I want, whether that's Monzi or Kserve or even locally on my own machine. Go back to here. And so just a quick kind of overview of that's how Chassis works. It was just that easy. It was about 20 lines of code, right? How it's actually working internally is that Chassis is taking the model that you give it, along with that processing code, and then just simply wrapping it in essentially an interface class that allows us to have a common way to access your model and that process method that you provided. And then the Chassis SDK locally grabbed a hold of some of this other data that you pointed it towards, right? You pointed it towards for example, the sample input data. We're going to use that during the packaging process for the OMI compliance. And a couple of other things under the hood that you didn't actually have to provide. One of the things that Chassis does is it takes a look at your Python environment, for example, grabs all the modules that you're going to need, and pretty much anything that's going to be required to recreate the environment that the model itself is running in. That way the container that emerges from the other side, as far as the model is concerned, would be indistinguishable from the environment that the model happens to be running in locally on your machine. So there's no situation in which you have some sort of special environmental setup or dependencies that aren't available kind of outside your R&D world. So once the Chassis SDK has all that ancillary data in your model, it creates a request object from the Python request module and submits it via an HTTP call over into the Chassis server. The Chassis server then receives it on a Kubernetes cluster at an ingress, which forwards it to the Chassis API server's pod. The Chassis API server then takes the request that you sent, which included your model and all that ancillary data, pulls it apart so that it can get a hold of your model, and then takes a look at a series of Docker files and other Python kind of boilerplate that was created to be OMI compliant. And then using your model and the OMI compliant Docker files and their ancillary data, it issues a call to an open source project called Canico, which fuses those together to create for you on the other end a container that is OMI compliant and ships it on off to Docker. And that's it. That's overall how Chassis works. And it's a pretty simple, straightforward way for you to take your models and turn them into containers. And we talked earlier about the fact that we built Chassis to help kind of bridge this divide that existed between data scientists as well as DevOps teams. And that's where we continue to go with the Chassis along the way. It's proven to be a valuable sort of capability for turning models with high potential into actual containers, whether those containers are sitting on a DevOps cluster, or they're sitting in some sort of IoT device, or they're processing massive amounts of information. And so I think with that, we'll go ahead and stop and take any questions that you guys might have.